What's going on, you guys? Mr. Allen here. So you have when dividing f of x equals that polynomial right there by p of x equals x plus 6, the remainder is 7. What does this tell us? So this is just a general idea here. What's going on when we're dividing polynomials by monomials or whatever it may be. If the remainder is 7, we know that x plus 6 is not a factor of that f of x function right there. It's not a factor because it has a remainder. What else do we know? Well, could I say that p of, say, negative 6, right, if x plus 6 equals 0, and I solve that, if I do substitution with negative 6 and evaluate it, I'm going to get 7, right? Because my remainder matches what we would get when we evaluate the polynomial at that specific value. Don't believe me? Check this out. If I had negative 6 in the box for synthetic division, and I had 1, 5, negative 3, and 25, and I go through the process, drop that 1, negative 6 times 1 is negative 6, add them, I get negative 1, multiply, I get 6, add them, I get 3, multiply, I get negative 18, which leaves me with 7 for my remainder, right? This is my remainder, my constant, my x, and my x squared. So I'd have x squared minus x plus 3 plus a remainder of 7 divided by what I was dividing by, which is x plus 6. So that's what we would have right there, right? My remainder is 7. If I were to directly substitute negative 6 in there, I'd get 7, so on and so forth. Now, what else would be true here? Can I get anything else out of this? I'm just thinking maybe even like multiple choice type questions where they're like, select all that apply, or find one that's true or one that's not true, right? Could I rewrite f of x like this? Let's see here. So if I had f of x, we could say that it is equal to this guy right here, right? This whole mess right here. So x squared, and I'm going to leave a little space here for a reason. X squared minus x plus 3 plus 7 over x plus 6. But I could multiply that x plus 6 back in, right? And this would be equivalent to the original one, right? Here's where it is divided out, and then if I multiply back in, it's equivalent, right? Could I see that in any other way? Well, perhaps as well, right? So if I were to say multiply this x plus 6 to this whole thing and that, I want to treat these two as separate guys right here. So that's one thing, that is another. If I multiply it out, I'm going to leave it as x plus 6 times x squared minus x plus 3. But what happens when I multiply x plus 6 to this one right here? The x plus 6's will cancel because that's going to be in my numerator. That's in my denominator, leaving me with just 7. Right? So that's a whole lot of stuff that we know here based on it just being a remainder of 7, right? We went through the process of synthetic division. We don't have to necessarily do that, but that was just to showcase that wonderful stuff right there. So direct substitution can equal my remainder, right? I could have it as what I was dividing by, multiplied by what I got, and my remainder right there. That's an equivalent form. That's an equivalent form. That's a whole lot of good stuff right there. That's a lot of dope stuff, man. Hope you guys enjoyed it. I certainly very much enjoyed it. It was awesome, just like you guys. See you later.